Time for another DraftPhysics.com video presentation. So the bowling ball example in the mv versus 1/2 mv squared controversy. The 300-year-old argument that was suspended for no good reason and for which the wrong side has won, decisively won. Okay. But it's just the wrong answer. So in the bowling ball example, you can have a 16-pound ball going 8 miles an hour or an 8-pound ball going 16 miles an hour. The argument would be that according to momentum, they have exactly the same energy, but according to the kinetic energy formula, the energy of the lighter ball is double, with the assumption that somehow it'll do more work. It'll do twice as much work because it has twice as many joules. It should be understood a joule, okay, is really a Newton falling 1 meter, which is actually the weight of a kilogram. So in a sense, when they say joules, these numbers, this means 512 kilograms, which is, 1,000 pounds or more. So they're saying that a 16-pound ball going 8 miles an hour weighs over 1,000 pounds, and they're saying an 8-pound ball going 16 miles an hour weighs over 2,500 pounds. Which numbers seem more realistic, 128 or 2,000, 2,500? Imagine throwing a steel ball back and forth, a 2-pound ball going 5 miles an hour or a 5-pound ball going 2 miles an hour. The fact is you're catching the same thing. You're catching a weight, okay, and the weight is momentum. Now, the lever again proves that this doesn't make any sense, this kinetic energy formula, that the answer isn't the right answer, because if they did have a tug-of-war, it would be a tie. And you can think about it as a lever argument. If I put 16 pounds on a lever and then two distances away I put 8 pounds, the fact is they'll weigh the same. They will, according to gravity, they'll be doing the same work, okay, and they'll balance. And the same is true for their momentum. If I give them proportional velocities to inverse to their weights, I'll get the same answer. They will weigh 128 pounds each. When they hit the scale, this one is not going to display its 2x power. It's not going to be there. We won't be able to see any 2x, twice as much energy. This side won't go pushing through, and this side won't be thrown back. The two will hit, and there'll be a lot of tension in the lever, but there won't be a winner. And so I have charted this out. The fact is, you can just think of what the 8-pound ball is going to do is it's going to distribute its energy quickly. So in the first moments, it's going to be giving away more energy. So it's going to be losing its momentum quickly because everything it hits, it's going to give a lot of energy too, because it can give a higher velocity. Things only give the velocity they have. If a 10-ton train hits me going 5 miles an hour, I can only leave the train at 5 miles an hour. So I can only have a momentum that's 5 times something. If a 5-ton train going 10 miles an hour hits me, I can leave at 10 miles an hour. Therefore, my momentum is going to be 10 times my weight. So I'm going to collect more energy from the train. But the fact is the 10-ton train going 5 miles an hour or the 16-pound bowling ball, okay, although it loses in the beginning, it wins in the end. And this will equal that. And that's the simple truth, that over the long term, it will produce just as much energy. It'll produce just as much work. This is garbage. Okay, this is the truth. It always was the truth. Newton and Descartes knew this truth, and their physics worked. There was no reason to fix it. It wasn't broken, and they did it for no good real reason. It was a religious idea shoved into physics, and then it was supported by people who weren't very scientific, and that's the truth. There weren't evidence. There wasn't experiments. It was all just a story told, a wishful thinking. So I have charted the 16-pound ball against the 8-pound ball, and you can see, the first pin leaves with 35 momentums, in the case of the 8-pound ball, and in the case of the 16-pound ball, it's only 20. So a huge differential on the first pin. But soon, very quickly, 4 pins. Once you get to the 4th pin, then you're talking that they're going to start giving away the same amount of energy. And then for the rest of the time, it's going to be the 16-pound ball that has retained most of its energy, most of its momentum, that will be doing substantially more work with each pin. You know, it'll start being 3 times more energy given per pin, and it'll do it much longer. Even after 13 pins, the 16-pound ball still has 12 momentums, joules, left, and the 8-pound ball only has 1.9. And if you add up all the momentums in the pins, it works out just fine. It all comes back to 128. And this is the rational way to understand how energy is conveyed from an object. And there's no way to make the kinetic energy formula make any sense in this context, because you can't establish these proper velocities. But the fact is, you can't give a speed faster than you can push. You can't push something faster than you can run, for example. And the same is true with all these other physical objects. So unless you use something like a spring or some sort of compression device that stores energy, you can't give something more velocity than you have to give. So it's all quite simple, quite obvious. Momentum works. It works really, really well. And kinetic energy doesn't work. It fails all the tests. If they actually would test it, it would fail the tests. If they actually did these simple tug-of-war experiments, put a 10-ton train going 5 miles an hour on one side of the rope, put a 5-ton train going 10, 5-ton train going 10, 10-ton going 5 on either side of a tug-of-war rope, and the lighter train will not win. It's just a fact. It's a fact you can understand. Intuition isn't a great thing to run your life based on, but the fact is every intuition, all of your common experiences are the fact that you can't push something faster than you can move. You can't throw a ball faster than you can move your arm. These are just facts. And the kinetic energy formula doesn't care about any of those common experienced facts. Again, they're telling you that an 8-pound bowling ball does twice as much damage, twice as much work, moves twice as many atoms twice as far. And there's no logical reason for you to think that's true. Until they show you some real evidence, you shouldn't believe it. And that's the truth. This has been a DraftPhysics.com video presentation.